Hello everyone, welcome to session number 3 of Concept Booster series. So today we are going to take a very beautiful topic, that is permutations, and we are going to learn permutations like never before. You may have not learned permutations like this. Okay, we will understand the concept of permutations from the perspective of functions. We will see what is a bijective function, what is an injective function, and with the help of that we will first of all we will define the concepts of permutations and k permutations. Okay, so let's get started with today's session. First of all, this is an introduction about myself. I am a IPM student who is currently in the 5th year at IIM Indore, and you can check out our courses in our webpage, and you can visit our webpage at www.cipmat.in, and you can check out the various courses at all these various links. Also, you can follow us in our various social media handles in Instagram, YouTube, LinkedIn, WhatsApp. Of course, if you like the video, please hit the like button and also share the video with your friends. Let's start the class for today. Here are some tips for cracking IPMAT. Do go through it. You will find the PDF of today's class attached in the description box. So please make the full use of the whole thing. The first concept that we are going to learn in today's class is the concept of words. Now, what is a word? Okay, ध्यान से समझना सब लोग, ठीक है? देखो, let's say that let A be a finite set. Okay, let's say that A is a finite set. I know what is a set. What is a set? Set is a collection of well-defined objects. What is a finite set? If the cardinality of the set can be defined, that is, if it does not contain infinite number of elements, okay, then it will be called as a finite set. Okay, where you can count the number of elements and it is exhaustive. Only then we call that kind of a set as a finite set. Okay, now how do we define a word in concept of permutations and combination? We define a word as a finite sequence of elements of this particular set A. Okay, so how is a word defined? Let me write it down over here. A word is a finite sequence, is a finite sequence of elements of A, of elements of A. There is a small prerequisite for this video. I will assume that you guys have the basic idea of set theory and you have also learned the basic concepts of relations and functions in your school before. Now, with the help of those concepts, we will be learning the concepts today. Okay, so word is a finite sequence of elements of this particular set A. So let's take an example for that matter. Okay, suppose let's say that we can take an example. Let's say A is made up of elements like 1, 2, 3, 4, 5, 6. Okay, let's make some 3-letter words. Okay, to make a 3-letter word, we can have examples from there. For example, it can be 121, 113, 115, 226. Okay, 14, 134. Okay, then it's 232 and 333. Okay, it can go on like this. So these are all 3-letter words from this particular set. Okay, I hope this is clear to everyone. This is a very easy concept. Okay, then now comes the first theorem or the first concept related to words. Okay, you must have learned this concept before, but look into it from a different perspective today. What is that perspective? The perspective is a theorem. What is this theorem? Let's learn this. The theorem is that the number of words of length, the number of words of length k in an alphabet, where what is an alphabet? We call this as an alphabet. Okay, the whole set. Okay, this whole set of A is known as an alphabet. The number of words of length k in an alphabet, okay, consisting of n letters, consisting of n letters is what? Is n to the power k. Okay, you must have heard this before, n to the power k टाइप का permutations. ठीक है, अभी देखो यहाँ पे इसका proof देखते हैं. ठीक है, so what is the proof for this? The proof for this will be something like this, that is, you see that I want to make a word of length k. That means I have this as the first place, second place, third place. In this way, I have k places. Okay, this is place number 1. This is place 2. This is place 3, and in this way we go till place k. Okay, I hope this is clear to everyone. Okay, now how many possibilities? I have to choose some word, I have to choose some letters from the alphabet of length n, right? I have a pool of letters over here. Okay, and how many letters are there? There are a total of n letters. So from these n letters, how many ways can I fill these k places? Okay, these k places, though repetition is allowed, because over here you can see in the examples, repetition is allowed over here. Okay, so how many words of length k in an alphabet consisting of n letters can be formed? You see, the first place, how many possibilities are there? The number of possibilities for the first place is n. The number of possibilities for the second place is going to be what? N. The number of possibilities for the third place is going to be what? N. In this way, the number of possibilities for the kth place is going to be what? It is n again. Hence, I can say that the number of ways in which I can fill all the places is going to be what? The total number of words. The total number of words that can be formed is going to be what? It's simply n multiplied by n multiplied by n. In this way you go on, and how many terms will be there? There will be a total of k times you are going to multiply this number n. Hence this is going to be equals to n to the power k. Okay, this is going to be equal to n to the power k. Now let's understand this particular concept with the help of some functions, with the help of some sets and relations. Let me make some space for myself over here. Okay, I think that's good enough, and it's visible. Okay, I will write the concept over here. So let's say that, see, the same concept is going to be illustrated with the help of certain sets. Look into it very carefully. Okay, suppose there is a relation from two sets x to y. Okay, there is a relation from x to y. Let's say that I have one set which is x, and I have another set, let's say that is y. All right, and let's say the number of elements in x is equals to k, and the number of elements in y, this is equal to n. And let's say that the elements over here, are something like this. Okay, they are over here, and the elements over here are something like this, in this way. All right, now you can see that how many ways can I map this particular set of sets. How can I do that? Okay, here are k elements. To the first element, how many choices do I have to map this element? Okay, I can have a total of n choices, because there are total of n options. Similarly, this one will have how many choices? It can go to the same element as well, right? That is how functions are defined. You know, that from x I can, two elements can be mapped to the same element in the other set, right? So that is what we know from functions. So let's say this is mapped to this particular element, and it goes on like this. So for every element, it is going to have n choices again. Okay, so number of maps, if I say the number of maps from x to y is going to be what again? It is going to be n to the power k. Okay, so in functions, if somebody asks you, okay, this is a possible question in the examination, that is, how many possible maps can be there from one set x of cardinality k to another set y of cardinality n? How many possible functions can I make? How many possible relations can I make from x to y? Your answer should be what? your answer should be n to the power k. Okay, how many maps you can make from x to the x to y? It's going to be n to the power k. I hope this is absolutely clear to you. Okay, and this function f, it corresponds to the word which is made up of f of 1, f of 2 in this way. Like if these elements are like 1, 2 and so on, okay, it will go on with a set like f of 1, f of 2, and in this way it will go on. Okay, but yeah, till here I think this much you should be understanding. Okay, that is the number of maps from x to y should be what? N to the power k. So this is the whole concept of words. Okay, maybe this is a new concept for you, but the basic concept behind it is not new, because you have already learned this in the chapter of permutations and combination in detail. Now let's introduce two more concepts. One is the concept of permutations. Another one is the concept of k permutations. Okay, so let's see that what does all these things mean. So suppose you have a set. Okay, suppose you have a set x. Okay, and you have another set y. Okay, let's say that the number of elements in set x is k, and the number of elements in set y is n. Okay, and this time I want to calculate, what do I want to calculate? The number of bijections. The number of bijections. What are bijections? Do you remember? The bijections are nothing but one-to-one correspondence. That means no two elements in X can map to the same element in Y. Okay, this cannot happen. There is a one-to-one correspondence. What do you mean by bijection again? There is one-one correspondence. If there is a 1-1 correspondence, then I will say that it is a bijection over there. Okay, how do you calculate that? If I have, there are k elements over here, okay, and if there are n elements over here, every element should map to some different elements. Okay, every element should map to some different element. No two elements can map to the same element in Y. Okay, no two elements in X can map to the same element in Y. Now, this is how I can define a permutation, you see. So the definition of permutation would be something like this. That is, I can say that a permutation is a bijection. Okay, a permutation is a bijection from the set, let's say the set is having n elements, okay, 1, 2, 3 and so on till n. Okay, and if there is a one-to-one correspondence, then there should be one thing that should be matched. That is, every element should be mapping to some other element, some element in Y. There can be no element which is not there, like it's like which can be empty in X. Hence, there should be a thing, that is, this should be equal to this. That is, the number of elements in X should be equal to the number of elements in Y. Hence, permutation is a bijection from the set 1, 2, 3, 4 till n, okay, to itself only, okay, to itself. All right. Or equivalently, I can say that the permutations are the total number of linear orderings of this particular set 1 to n. Okay. What do I mean by linear orderings? So let's say that I say that these elements are 1, 2 and 3. These elements are again 1, this is 3 and this is 2. So see, 1 is mapped to 1 over here, 2 is mapped to 2 and 3 is mapped to 3 in this particular case. Okay, 1 is mapped to 1, 2 is mapped to 2 and 3 is mapped to 3. Okay, similarly there can be a separate diagram where I can map 1 to 3 and 2 to 1 and 3 to 2. Okay, in this way also I can do it. There can be any combination, any number of arrangements which can be there. Okay, so I should write a theorem about this. Okay, see, this definition of permutation is with respect to this functions wala definition. That is this set theory wala, relations wala definition, mapping wala definition. Okay, you guys have already learned about permutation before. That is, permutations is the number of arrangements of the n different objects. Okay, number of arrangements that you can make for n different objects. Yeah, फिर you can see that you how many ways you can arrange k objects out of n different objects. All these things you have learned before, but this is a different way to approach the concept of permutation. Okay, I will recommend everyone to first of all understand the basics of permutations, in the normal traditional way, and only then after that you understand these concepts in this video. Okay, so the theorem says that the number of permutations, the number of permutations, the number of permutations of the set 1, 2, 3 in this way till n, okay, is going to be what? सबको पता है, it is n factorial. N factorial क्या होता है? N into n minus 1, in this way it goes on till 3 into 2 into 1. Okay, the number of permutations of the set 1, 2, 3, 4 in this way till n is going to be n factorial. ठीक है, ये कैसे होता है? How is it done? You see, the first element over here, how many choices will it have? The number of the first element, how many choices will it have? It is going to have n choices in front of itself. Okay, the second element, how many choices will it have? It is going to have n minus 1 choices. Why n minus 1 choices? Because if I have already booked this particular thing to 1, okay, that means 2 cannot take 1 again. Okay, 2 cannot go to this 1 again. Okay, it cannot go to 1. It will have to choose among the rest of the elements. And how many elements are left now? There are n minus 1 choices. Similarly, the third element will have how many choices? It will have n minus 2 choices. Okay, in this way, if you go on till the nth element, the nth element will have only one choice in front of itself. That is, it will only have to take that position, or it should map to only that element, okay, which is not taken by the other elements till n minus 1. Okay, so how many total choices will be there? What should be the total number of permutations? The total number of permutations in this particular case is going to be n into n minus 1 into n minus 2. In this way, you go till 3 into 2 into 1, which is nothing but n factorial. Okay. And another thing is, now can you tell me what is the value of 0 factorial? And we all know that 0 factorial is equal to 1. Okay, but 0 factorial is equal to 1. Why? Here, n factorial is what? The number of permutations of the set 1, 2, 3, 4 till n, okay, to itself, right? It's a bijection to itself. Number of permutations, that is number of arrangements that n objects can have among itself. So how many ways can you arrange 0 objects? You don't have anything. Okay, that means only one arrangement is possible. Hence 0 factorial is equal to 1. Okay, so this is the combinatorial approach through which you can say that 0 factorial is equal to 1. There are other approaches as well where you can prove 0 factorial equals to 1 using some algebraic techniques. Now let's move forward and understand the concept of k permutations. K permutations क्या होता है? You see, it's that concept जहाँ पे suppose there are a total of n people. Okay, there are a total of n people, and suppose there is a door over here. Okay, this is a door, and here I have only k seats. Okay, I have only k seats. Okay, now how many ways can I arrange k people after selecting k people from the n people? So here you need to do two things. First of all, you need to select the k people out of n people. Okay, and then you have to arrange them in k different seats. Okay, this is the thing that I want to achieve. So this is what I want to achieve, right? The number of ways in which k people can be seated out of n people. So this is what is a K permutation as well. That is, I can say that a K permutation is a total number of linear orderings. Okay, is the total number of linear orderings on a K element subset of 1 2 in this way till n. Okay, so here basically in the previous case, if anybody asked you about bijections, you can answer it's n factorial. Okay, number of mappings from x to y, number of bijections from x to y was n factorial. That you have already learned. Here it is injections. Okay, here we are talking about injective maps. How is it so? We will see in a while. So what is K permutation? It is the total number of linear orderings on a K element subset of 1 to n. Okay, what does this mean? See, some examples first of all, let's see, and then we will move forward to understand the concept in detail. So let's say that I have n is equals to 4. Okay, let's say the elements are 1 2 3 and 4. Okay, then there can be one permutation. What is one permutation? One permutation means select any one. It can be done in 4 ways. Either select 1 or select 2 or select 3 or select 4. Okay, then how many 2 permutations are possible? There are various 2 permutations which are possible as well, like 1 2 2 1, 1 3 3 1, 1 4 4 1, and in this way it goes on till like 3 4 and 4 3 in this way. All right, so there are various 2 permutations which are possible. Then there are 3 permutations which are possible as well. Then I can say that the number of, you see, the number of K permutations, the number of K permutations of this particular set, let's say 1 2 3 till n, okay, is going to be what? It should be equals to NPK that you have learned before. What is it? This NPK? NPK is nothing but n into n minus 1. In this way it goes on till n minus k plus 1. Okay, or the normal notation that you know, n factorial by n minus k factorial. Okay, what is the proof for this? The proof for this goes on something like this. That is, for the first entry, okay, for the first entry, how many possibilities are there? That is, this particular seat can be occupied by how many people? What are the number of possibilities? The number of possibilities is n. This particular seat can be occupied by how many people? What are the number of possibilities? It is n minus 1, because already the first seat is taken by one person. How many ways can this particular seat be taken? It is n minus 2. In this way, how many ways can the kth seat be taken? It should be n minus k plus 1. You see? So this is going to be nothing but n factorial upon n minus k factorial. Okay. So, and that is how we define this NPR or NPK over here. Okay. Now let's understand that how can K permutations be reflected with the help of functions. You see, suppose I have this set X. Okay, suppose I have the set X, and suppose I have a set Y over here. Okay, and let's say the number of elements of X is let's say K, and the number of elements of Y is equals to N. Okay, I want to find out the number of injective maps. Okay, I want to find out the number of injective maps. Now, what do I mean by injective maps? By injective maps, I mean that here there can be no such possibilities that from element X there is a map to a single element. Okay, this thing is totally not allowed. Okay, I want to find out the number of injective maps over here. So that is nothing but, you see, if I put in some elements like this, suppose there are k elements over here and there are n elements over here. Okay, a lot of elements over here. So you can clearly see that this particular element can be taken by any of the n elements. Okay, this particular element can be taken up by any of the n elements. This particular element can be taken up by any of the n elements. Similarly, this element can be taken up by any of the n elements. Okay. So here the number of injective maps is equal to the number of k permutations. Number of k permutations of this particular set 1, 2, 3 till n, and that is equal to what? npk. तो अगर किसी ने एग्जाम में पूछ लिया that what is the number of injective maps that you can find out, that will be equals to what? npk, number of injective maps from x to y, where x contains k elements and y contains n elements. यहाँ पे एक बहुत important factor है, that is k should be less than or equal to n for this to be true. Okay, so this is the concept of k permutation. So today I know that you have learned the concept of permutations from a different perspective altogether. Okay, but if you repeat this video, see this video once again, you will see that how you can relate these concepts, relate the concepts of permutations with the concepts of relations and functions. Okay, and एग्जाम में बहुत बार ऐसे पूछे जा सकते हैं. The 3 things that you need to take from this video is this one. That is, first of all, the number of maps that you can take from x to y. Okay, the number of maps that you can take from x to y such that x has k elements. Okay, I'm talking about this part over here. Okay, the number of maps from x to y such that x contains k elements and y contains n elements will be what? N to the power k. Okay, n to the power k. Here this thing is allowed. Okay, this thing is totally allowed. Then after that, if you ask me that what is the number of bijections, okay, what is the number of bijections? First of all, for a bijection to occur, okay, there's for a 1-to-1 correspondence, 1-1 on 2, basically 1-1 on 2 correspondence. Okay, I need to have the number of elements in x to be equal to number of elements in y. That is, the cardinality of x should be equal to the cardinality of y. Okay, only then I can define a bijection. Then how many bijections can I form? The number of bijections are going to be n factorial. Okay, it should be n factorial. Next thing that you should take from this particular video is this. That is the number of injective maps from x to y, where where x is having k elements, y is having n elements, such that k is less than equal to n. Okay, then the number of injections is going to be what? npk. Exam mein पूछे जा सकते हैं. So keep this thing in mind, and that will be it for today's video. Okay, if you have any doubts, please mention in the comment box. If you like the video, please like this video and share the video. Please subscribe to our channel as well, and do contact us at these important links to subscribe to our courses and join our Instagram handle and the various other social media channels as well. So thank you for watching the video. If you have any doubts, please mention that in the comments. And if you have any views regarding the video, you can also express that in the comments, as long as you are respectful. Okay, that will be about it for today's class. It was thanks for listening to me, and it was a pleasure to give you this lecture. Bye-bye. See you in the next lecture.